Hello class. Today we're looking at writing an absolute value equation from a graph. So you may want to pause the video and write this all down. Okay, so we're going to start off first of all writing the equation for this absolute value function here. Okay, so in green I have shown you the parent function. F of x equals the absolute value of x. So what we're going to do is we're going to write the equation for the transformed function. So the first thing you want to do is identify the new vertex. So the original vertex was at 0, 0 for the parent, and the new vertex is now at 2, 1. So in this case, 2, 1. Now from the last video, recall the transformed function that we talked about. And that was, we're going to go ahead and use f of x equals a, recall, is your vertical stretch or compression. Your b value, which is your horizontal stretch or compression. Then you have your grouping, which has your x minus h. H is your horizontal translation. And then your k value, which is your vertical translation. Okay? So to write this, first of all, when you identify your new vertex, you have just found your h value and your k value. Now, when we write the equations for these functions, these transformed ones, we will be able to identify a, h, and k. We will not be doing any graphs that have a horizontal stretch or compression. Okay? So right now, as we build this equation, we're going to have, starting off, x minus 2. Because it's been translated 2 units to the right. And remember that inside anything dealing with horizontal, inside the absolute value grouping symbol is going to be the opposite. So since we moved right 2, it's going to be x minus 2. Okay? And as I said before, we're not going to be dealing with any horizontal stretches or compressions. So I'm going to put my absolute value symbols on this because we have an absolute value function. And then our k value is 1. And it is what it is. It's moved up 1 unit, so plus 1. Okay, to find a, well, first of all, let's look at the a value on the parent. If you look at the parent function, the a value is 1. And why is that? Well, that's because when you go over 1, you go up 1. And that's how you calculate the a value. That is your a value. So in this case, and it doesn't matter since it's symmetrical on both sides, it doesn't matter which way you go. So if we go over 1 unit, the a value in this case is going to be 1. Okay, so the a value is 1, so our function is going to be this for this graph. Okay, let's take a look at another example. This time, we have another parameter being affected. Can you tell which parameter is being affected this time? Yes, we have a vertical stretch. Notice that the graph appears to be narrower okay? And that is because the y-coordinates have all been stretched. They've all been multiplied by a number. We've got to figure out what that number is. But the first thing we're going to do here for our success criteria is identify the new vertex. That's always the first thing you want to find. So our new vertex is going to be at -3, -2. You should identify that. Go ahead and label those coordinates as h and k. And then we're going to go ahead and plug them into our function as we build this equation. So starting off inside the parentheses, we would have x minus h. So that would be x minus -3. Okay, putting on our absolute value symbols because that's the type of function we're dealing with here. And our k value is -2. Now, to find the a value, as stated before, the a value, the simplest way to find that is to go over just one unit from the vertex and then count to the graph. So in this case, for the parent, remember, it was 1. And that represented a. A value is 1. So in this case, we go over one unit. Remember, it doesn't matter which direction in this case because it is symmetrical on both sides. Go over one unit and count to the graph, the nearest point, and here it's 2 units. So in this case, the a value is 2. And remember, when the a value is greater than 1, this tells us we have a vertical stretch. Okay, and that happens if a is greater than 1. Okay, we can go ahead and rewrite this so that way we have the, it's in the simplified version. So let's go ahead and rewrite this real quick. And this way you can see that even though it has a coordinate of -3, when you simplify it, it says plus, and I don't know why I put 4 there. I need another cup of coffee this morning, obviously. So plus 3. So 3 units to the left. Okay. So now, if we were to apply this information to our parent table, let's do that and see what we get here. So let's go ahead and apply to the y first. So like before, I said the outside of the absolute value bars is going to affect y. So order of operations tells us to do multiplying first. Then subtract 2. This is going to give us our new y coordinate. So let's take a look. 3 times 2 is 6. 6 minus 2 is 4. Going to go relatively quickly now. Pretty simple calculations here. Hopefully I don't make any mistakes. Yes, I did make a mistake right here. Okay. I'm not going to redo the video over that. Okay, so these are our new y coordinates. Okay, let's take a look at x now. Okay, So we have plus 3, which means we're going to subtract 3. So subtracting 3. All right, let's find out if we have the right graph here. So we have -6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Yes, bullseye. -5, 2. 1, 2, 3, 4, 5. 1, 2. Yes, bullseye. -4, 0. And here is another mistake, Mr. Kramer. 0 minus 2 is -2. So -3, -2. And -2, 0. And -1, 2. Now notice, similar to quadratic, we have that symmetry going on around the vertex. We have that symmetry happening. Okay, guys. Thanks for paying attention and listening and writing this all down. Come to class tomorrow with your questions.